In this video, we are going to look at solving a basic trigonometric equation involving sine or cosine. So our problems are going to look like find all the solutions of and then some trig function. It's trig equation. So here in this one, I happen to have sine theta equals 1/2. So I want to find all the places where the sine of theta is equal to 1/2. So the first thing I'm going to do is, if I look on the unit circle, where the sine of theta is equal to 1/2 is here at pi over 6, and then also here at 5 pi over 6. But we didn't ask for just one time or two times. We asked for all the times. So if you think about it, it happens here at pi over 6, but it would also happen if I went all the way around the unit circle and then came back again another pi over 6. Or if I went around 1, 2, 3, 4, 5 times and then came over this much. So there are an infinite number of places where this occurs. And so we need a way to write that. So the first thing is what's going to happen is it definitely happens at pi over 6 and it definitely happens at 5 pi over 6. But now I need to take care of going around the circle multiple times. So if we think about going around the circle multiple times, I was here, so I'm here at pi over 6, and now I'm going to go all the way around one more time. Well, every time I go all the way around, that's 2 pi. So we could add pi over 6 plus 2k pi. And so the reason why we put this k is because we're saying you can go around any number of times. So if you go around once, k would be a 1. If you go around 4 times, k is going to be a 4. So this is the generic way of saying, hey, start at pi over 6 and then go around as many times as you need to get all of the answers, right? And we can go around an infinite number of times. Same thing here, we'd have 5 pi over 6 plus 2k pi. So if you're given a problem and there's no interval, they didn't give you an interval to say find the solutions in the interval between 0 and 2 pi, you're going to need to add on this plus 2k pi part onto the answers that you would get off of the unit circle. You also will see added after this 2k pi part will be this k is in z, and all they're saying there is that k is an integer. So the k in z is just letting you know that k is an integer. And so basically it's saying I'm adding whole number amounts of times around the circle, right? And I could go forward around the circle or I could go backwards. So that's why we can have positive numbers or negative numbers. So we'll try another one here, just so we kind of get the gist of what is going on. So b 2 cosine theta minus root 3 equals 0. So I'm going to add root 3 to both sides. So 2 cosine theta equals root 3. Divide both sides by 2. So the cosine of theta is going to be equal to root 3 over 2. So I'll do these in blue here. So if we're looking for where the cosine, so where the x value is root 3 over 2. So one of the places happens to be here again at pi over 6. The other place we're looking for x, this time being root 3 over 2, is here at 11 pi over 6. So that's what I'm going to start with. I'm going to start with theta is pi over 6, or theta is 11 pi over 6. And then since I wasn't given that interval, I have to add it on. So it's going to be plus 2k pi, where k is in the integers. So plus 2k pi, again, where k is in the integers. And so when you're not given an interval at the beginning of your problem, that's when you have to add on this plus 2k pi.